Okay, hello students. There's a couple of things that I did not teach you, and yet they show up on your ALEKS. So I want to make sure that I explain it to you, and it has to do with what happens to our K, our equilibrium constant, when a reaction is reversed, multiplied by a coefficient, or added to another reaction. So 3 things that we've got to worry about. Let's talk about the first one. We're going to make up a fake reaction here. 2A plus B goes to C. Very creative, I know. Let's call this K1, our equilibrium constant for that reaction. Now, if we wrote out the expression for this, we would get our concentration of C divided by the concentration of A squared times B. That's our K expression. So the first question is, what happens if instead of the reaction being written in this direction, it was actually reversed? So we have C becoming 2A and B. Well, if I write out this expression for our equilibrium constant, I would get A squared times B over C. So how are these two related? My K2 is just 1 over K1. It's just the inverse. I put this squared on the wrong place. Hold on. It goes like that, okay? Our K is just the inverse. So if I reverse a reaction, my new K is 1 over the old K. Okay, K prime is 1 over K. That's my rule for if I reverse the reaction. Now, what if instead of reversing it, I'm going to now multiply by a coefficient? So let's take my same reaction, 2A plus B makes C. And we're going to say now our K is 100, just picking an easy number here. And now, for whatever reason, I've got to multiply this whole thing by 2. I need 4 A's. So I've got to multiply this by 2. If I write out my expression for my first reaction, my K1 here, I get C over A squared times B. And if I write it out for this second reaction, I get C squared over A to the 4th times B squared. So how are these two related? What did I do? All I did was I squared my original K and to get my new K. So this equals K1 squared. So in this case, we'd get 10,000. Okay, so I just square the value. So whatever my multiplication is, that's the power that I raise my K to. So when I multiply a reaction by a coefficient, it doesn't have to be a whole number. It could be a fraction like 1/2 as well. If I multiply a reaction by a coefficient, the K is raised to that power. My new K is my original K raised to, we'll say it's X, the X power, okay? That's the second thing that you need to know. Third thing that we need to know is what happens if I have 2 reactions and I'm adding them together. So let's take our same reaction, 2A plus B makes C. We said our K1 here is 100. And now let's add on another reaction. So let's have C we'll make it super easy. It goes to D. Okay, and this one is going to have a K2, and let's say this K2 is 10. Going with easy numbers here. Okay, so I'm going to add these guys together. When I do, this C cancels out. I get 2A plus B makes D when I add them together. What do I do with my K? Well, let's look at the expressions. I've got C over A squared times B for the first one. I've got D over C for the second one. And the third one is D over A squared times B. So how is this one? How do these two play into this one? What did I do? I just multiplied them together. When I multiply them together, the C on top up here and the C on the bottom here cancel out, and I end up with my overall expression. So my rule is when I add reactions, I multiply the K's. So if I have my new K, it is going to be K1 times K2. Okay, now I should note you can combine these rules together. Just do one thing at a time. For example, if I needed to multiply one of these reactions, I would multiply it and get the new K that's raised to that power. And then when I'm adding the reactions together, I just multiply them by each other. Now, you may remember these rules are different than what we did with delta H or delta G or delta S. In those cases, we were using addition, right? We would switch the sign, or just if we multiplied, we multiplied. And here, for K, we're doing, it's all like multiplication or exponential. So when I reverse the reaction, I get the inverse instead of just changing the sign. And when I multiply by a coefficient, I raise it to that power instead of just multiplying, etc. When I add them together, instead of just adding, I multiply. So the rules are a little bit different here for the K's than they are for the other things. Now, this should affect questions 6 and 7 on your ALEKS, and we will talk more about this next week, but I wanted to just send this to you so that you're aware of it to do those problems for this week. Thanks.